Hello everyone, welcome to Reactify Labs. Today I'm going to talk about consistent hashing. In the last video about load balancing, I talked about different approaches which are used for load balancing, but how each approach had its own limitation, right? So we had round robin with a limitation, we had IP hashing with limitation. So each of those had their limitations. So we prefer to use consistent hashing. And in this video, I'll talk in more detail about what consistent hashing is and how it works. So let's write it down. Consistent hashing. Okay. So if we go by definition, it's I think I have talked about the definition in the last video, so I'll just reiterate it. Consistent hashing is a distributed hashing scheme. Distributed hashing scheme that that operates independently of the number of servers. As we have noticed in other approaches that they are dependent on the number of servers, but this one is independent of the number of servers. Okay. Or instead of servers we can also say objects in a distributed hash table in a distributed hash table by assigning them a position where on abstract circle. The circle is not a real circle, it's an abstract circle, or it is also called or hash ring, by assigning them a position on abstract circle or hash ring. So what it does, it creates virtual replicas of servers. Why? To avoid skewed distribution of load. If you remember, I have talked about how the load gets skewed in different approaches. Round robin had its way of skewing the load. Similarly, least connection had that the assigner, the mediator, does not consider the power of the load, and it only takes into account the least number of connections, which also causes an skew. Similarly, IP hashing method also causes an skew if the mm, modulus function is not properly calibrated. Okay, so let's go and see how the example works. So before that, let me show you one thing. Just see that if we consider the round robin method again, if you see, I had made it like this, but actually, if you see, it goes like this. If something has mod 5, okay, and if it is 0, it comes here. For 1, it comes here. For 2, 3, 4. But if something mod 5 is equal to 5, then this mod 5 is 0, right? So basically, if it's 0, 5, 10, 15, all mod 5 is 0. So this is also circular actually, right? So we would not be wrong if we write it like this. Okay. So this is also circular. Round robin is also circular. All the hash methods are all still circular. But in this consistent hashing, we still, it has circular, but I'll represent it in circle. Okay, like this. So this is a circle, and this is abstract circle or hash ring, as we would call them. So let's see how this works. We'll take an example. For now, let's say we have 4 servers. Okay, we have 4 servers to serve the requests. Okay, and we have a value called k. Okay, so what we will do is we will take each server, okay, server 1, and we will do it mod k, not mod k directly, we will hash it. We have some hash function, hash 1 mod k. Okay, we have server 2, we will hash it mod k. Again we have server 3, hash it mod k, and same for server 4, hash it mod k. Okay, let's assume we have a circle in which the values are from 0 to 99. Okay, 0, 1, 2, 3, 97, 98, like this. Okay, 50 here. So the values are like this. So what happens is when we mod this, so in this case the k will be 100, right? And this is independent of the number of servers. We don't care how many servers are there. So if you see now, if let's say this mod k comes out to be 10, this comes out to be 40, this comes out to be 60, this comes out to be 70. So we will place these servers. Okay, so we'll place these servers here. This is 0. Here we have at 10 server 1, at 40 we have server 2, at 60 we have server 3, and let's not take it 70, 70 is very close, 80. Okay, at 80, yeah, at 80 we have 1, 2, 3, 4, server 4. Okay, now I'll just remove this 0. I'll remove this also. Oh, sorry. Okay, so now the servers are independently placed. Now what happens is, let's say the request comes. So there is request 1. Again we will use the same hash function for request 1. We will mod it using k. Okay, we will see, okay, this value, if this comes 10, then obviously it will go directly to 10. If it's something like 15, okay, 10 is fine. If it's something like 15, so the 15 will come and it will see, it will go in the clockwise direction and see which is the nearest server. So it will come here and it will go till 40. Next, for another request, let's say, okay, let me be more clear here. So the 15 will obviously go here, but let's say it's for another request, hash of request 2 mod k. If this is 15, so this 15 will go here. Okay, similarly for next request, if it is request 3 mod k, if it is 70, actually let's say it's 85, then what happens, 85 will come somewhere here, it will go like this till here. Okay, the 85 will go there. So this is how the requests are distributed, but it's not consistent hashing. There is some problem with this. The problem is, what happens if this server goes down? Let's say here there are multiple requests, 20, 25, 30, like this. Here we have 100 requests and this server S2 goes down. What happens is all these 100 requests will come to this server, right? We solved that problem, that we don't have to redistribute everything, because obviously the hash function will not change. Earlier what was happening was, if we had 4 servers, we were doing mod 4, now everything would do mod 3, right? But now it's not the case. The case is that, okay, it will just travels clockwise direction, and whichever the nearest circle comes, it will be served there. So if we already had x requests at this point, it now has 100 more requests, which is an extra load on this, and these do not get any extra load. So that is the drawback here. So that is also handled in consistent hashing. How? So what happens is, when we have this circle, so at 10 we had S1. Okay, I'll not mark it 10, I'll just say S1. Okay, this is 10. We had 40 S2, we had S3 at 60, and we had S4 at 80. Okay. Now what we do is we create replicas of these servers. So even though S4 is here, we will have a replica of S4 here also. We will have a replica of S3 here also. Let's say we have S1 replica here, S4 replica here, we have S1 replica here, we have S2 replica here, we have S3 replica here. Okay. So these are replicas. So I'll mark replicas with circles. Okay. So these are replicas. Now what happens when a request comes? So the request 15, if it comes, actually I need to mark it also. So let's say this is 20, this is 30, this is 40, this is 50, this is 55, 60, 70, 80, this is 85, this is 95. Okay. Now if a request 15 comes, so where will it go? The 15 will go here, 16 will go here, 17 will go here. How we are getting these numbers? The same thing, request coming, we are hashing it, and we are doing mod k, which we had decided earlier that k was 100. Okay. Now what happens is, let's say there are 100 requests here, then if this server goes down, okay, if this S4 goes down, then what happens? You will see that if this S4 goes down, this will go down from here, this will go down from here, this will go down from here. Now if you see, the requests got to S3. Okay, the requests came here. If this server went down, this request also came here. When this server went down, these requests came to S2. Okay. So I think actually if I just exchange the order, then this will be more clear. S1 and S4, let's say. So when this S4 goes down, the requests come to this server. When this S4 goes down, the requests come to S1. So if you see now, when S4 went down, then the requests got evenly distributed to S3, S1, and here S2. As you see, the requests are now evenly distributed. Even though it had 100, it is possible that this one also had 100, this one also had 100. It is possible, right? So the requests will get evenly distributed to all the other servers. Okay. I hope this gives you some idea. Next, if I take another example, for example, these are back again. Okay. Now, yeah. Now, since they are back again, let's take another example. When we added a new server, let's say we added a new server called S5. Okay. So what happened was, we did the hash for server 5, we did mod k, and let's say it came out to be something called 40, 50, 55, 90. Let's say it's 90. Then what happens is, this S5 will go at this point. Okay. This is 90. So S5 came at 90. Okay. Again, if we had this, so what would have happened earlier? In earlier cases, we had mod 4 in round robin IP hashing. We had mod 4, but now if server increased, we would be doing mod 5, and everything will have to be redistributed again. But here, this k is constant. K is independent of the number of servers, so the k will remain constant. So when S5 comes, it will not affect anybody. Only the requests which were going directly to S3 will now be distributed from every request before this point will go to S5, after this point will go to S3, and also along with this, S5 will also have its replicas. Okay. So the replicas will be, for example, let's say we put S5 here also, we put S5 here also, we put some S5 here also. So now what happens is, the requests got evenly distributed. Okay. All the requests which are going to S4 is now split between S5 S4, here S5 S4, here S5 S3, here also S5 S3, here it is split between S5 S1. Maybe it is possible that if we put something here also, it will split between S5 S1 also. We have done S5 S1, right? If we put something here, it will be split between S5 and S2 also. So this is how the consistent hashing works. It makes sure that the requests are evenly distributed by making sure that two things. One is here, back to the definition, independently of the number of servers, right? This is one very important point. It works independently of the number of servers. And second is, it creates virtual replicas of servers. It creates virtual replicas of servers and it works independently of the number of servers. So if I have to highlight two important things in this, I would say, just remember this point. Consistent hashing is a distributed hashing scheme. Distributed as in, because the systems are distributed. We have different types of system, different servers where we have to distribute the load. That's why distributed. Independently of the number of servers, by assigning them a position on abstract circular hash ring, and it creates virtual replicas of servers. Remember these two very important points and you will be able to explain everything about consistent hashing. So I hope this video clears any confusion about consistent hashing. And if you like the video, please give a thumbs up. Thank you for watching. Please remember to like, share and subscribe. I will see you in the next one.